All right, problem 3-105. Last one wore me out, but we'll keep on going here. Simplify the rational expressions below as much as possible. So problem A, we have our quantity of x minus 4 raised to the third power times the quantity of 2x minus 1. This is all being divided by the quantity of 2x minus 1 times the quantity of x minus 4 squared. Remember what these exponents mean. I'm not going to do this on every problem, but this is going to be the same thing as saying if we had x minus 4 times x minus 4 times x minus 4, then times our quantity of 2x, minus 1. Let me fix that right there. And that would have been over. And I'm going to rewrite the order here. I'm going to put my x minus 4s first. I'm going to have two of those. So I've got an x minus 4 times an x minus 4 times a 2x minus 1 here. Well, as we look to pull out our 1s, we can go through this. I can pull out a 1 here. This is also a 1. Remember, we're kind of shying away from saying canceling out because it doesn't just disappear. This becomes a giant 1. This is like a giant 1. Okay. Then we look here, 2x minus 1 and 2x minus 1. This is also going to be the same thing as 1. Anything divided by itself is going to be 1. So this would also be like a 1. So this is saying the quantity of x minus 4 times 1 times 1 times 1. That's pretty easy to simplify. We should end up with x minus 4. Now, do we have to show all this work? No. We should know here that if we have a group, or if we have x minus 4 here and it shows up as a factor 3 times in the top and 2 times in the bottom, it's going to create two 1s that we can pull out. And then our 2x minus 1s create 1 that we can pull out there. So 1 times 1 times 1 times x minus 4. We end up with that x minus 4. Let's look at B. B, we have 7m squared minus 22m plus 3, all divided by 3m squared minus 7m minus 6. A trinomial divided by a trinomial. There's nothing that can be simplified the way it is, because a trinomial must be simplified, or we can't pull out a 1 unless it has its same value in the bottom, and we have a different trinomial in our denominator. So let's see what the factors of 7m squared minus 22m plus 3 are. So I'm going to take this, I'm going to look to factor it into two binomials, because there aren't no common factors between 7, negative 22, and 3. So I'm going to have 7m and m. That's easy because 7's prime. So is 3. So when I put a 3 in here and a 1 in here, and I know both my signs are negative, I should have 7m minus 1 times the quantity of m minus 3. In my denominator, when we factor 3m squared minus 7m minus 6, and please remember, you may go ahead and use generic rectangles. As I walk around and check your papers and look to see if you've been doing your homework, I'm going to expect to see generic rectangles on many papers. If I don't, I'm going to be asking, well, how did you factor that? Some of you need to use the generic rectangles. There's nothing wrong with it. You'd rather do it right than just get what I got on here. So we have 3m. I'm going to have an m. And when I go through and do it here, I think I'm going to end up with 3 times 3 is going to be 9m's. And 2 times 1 is going to be 2m's. And I need to have more negatives. So that'll be a negative. This will be a positive. And just by coincidence here, look, we have two factors that are the same, one in the numerator, one in the denominator. As we work on this skill, get in the habit of looking for that. It's kind of a way to kind of cheat and help yourself out there. doesn't always work. If there's something that doesn't simplify down, you won't find the common factors. But many times when we're practicing finding the common factors, you can kind of help yourself figure out what it's going to factor into by looking for those. So this is like a giant 1 here. We have our m minus 3 and our m minus 3. So this is the same value as 1. So we have 1 times 7m minus 1, 1 times 3m plus 2. These do not simplify down anymore. So we end up with 7m minus 1 over 3m plus 2. Moving on to problem C. Now in problem C, similar to problem A, but we have a lot more quantities if we're going to write them out, and this is why we're not going to. I have the quantity of z plus 2 raised to the 9th power, so it shows up as a factor 9 times. We have the quantity of 4z minus 1 showing up as a factor 7 times, over z plus 2, once again, now it's a factor 10 times, and 4z minus 1 again showing up as a factor 5 times. So our first thing we'll look at is z plus 2. Does it show up as a factor more in the numerator or in the denominator? So you got to think about it. When we're taking out our 1s, we're going to take out 1 in the numerator with every 1 in the denominator. So we'd have 1 left over in our denominator, which leaves us with, so far, we could say this would be like saying a 1 over z plus 2, just to the first power. And we'd be multiplying that by, we have 4z minus 1 to the 7th, and we have 5 of them here. Well, for every 1 we have here, we're going to be removing 1 from the denominator. So what happens when we remove all 5 from the denominator? We're going to have 2 left over at the top. So we're going to have 4z minus 1 squared, because there's 2 of them left over, and everything on the bottom would have turned into a 1. So when we take this and we put it all back together, we just end up with 4z minus 1, this quantity squared, divided by the quantity of z plus 2. That would be our simplified answer there. And our last one, D, we have the quantity of x plus 2 times the trinomial x squared minus 6x plus 9 over the quantity of x minus 3 times the binomial x squared minus 4. As it is, there's nothing that definitely jumps out that I can pair up and take out the 1 with right now. But I suspect that this factors, and so does this. So let's go ahead and factor those. Our numerator should be x plus 2. And then x squared minus 6x plus 9. Well, that's a perfect square trinomial. We should end up with x minus 3 times x minus 3. And it takes me a lot less time to factor them, because I've been factoring for a long time there. Take your time, go ahead and factor them. If you need to pause the video to work it out and factor it, then you can unpause it to see if you're right or wrong. In our denominator, we're going to have an x minus 3. And we have x squared minus 4 here, which is a difference of squares. And we should recognize that that should turn into the square root of our first term plus the square root of our last term, and the square root of our first term minus the square root of our last term. So x plus 2 and x minus 2. Now we're looking for factors that will help us to pull out 1s. Well, I notice I have an x plus 2 in my numerator and I have an x plus 2 in my denominator. Rather than boxing them in and making a big 1, I'm just going to go ahead there, cancel them there. I know this is the same thing as 1, and this is the same thing as 1. And I know that I have an x minus 3 here, and I have an x minus 3 here, which makes that 1, makes this 1. And I'm left there with 1 times the quantity of x minus 3. So the quantity of x minus 3 over 1 times the quantity of x minus 2 leaves us with that. And that would be our simplified answer. Remember, a binomial has to be exactly the same as the binomial in the other side of the fraction, or in our numerator and our denominator, in order for it to cancel out. I cannot cancel out these x's because they are part of a factor. The factor here being x minus 3. It's a binomial. Can't cancel out part of a binomial. Hope this helps. If you have questions, please make sure you ask your teacher. Good luck.